I'll begin this afternoon session with a brief introduction. Welcome to the Canadian Institute of Forestry's National Electronic Lecture Program. My name is Sharon Young, and I will be hosting today's session. Today is Thursday, May 8th, 2025, and this is the second session in the e-lecture series entitled Greening Cities Together, Insights from Allied Professions on Shaping Urban Forest Futures. This series is brought to you by Tree Canada. The CIF-IFC is very pleased to collaborate with Dr. Ursula Eicker and the team at Tree Canada to host these webinars. Today's webinar is titled Urban Green Infrastructure to Improve Microclimate, Air Quality, and Walkability. A special reminder that the ISA-certified arborists are eligible to receive one continuing education unit for this webinar. Please email electures@cififc.org with your full name and your ISA certified ID in order to obtain the ISA continuing education unit. Once we verify your attendance, we'll send your information to ISA for them to process. Today, we have Dr. Ursula Eicker, Director of Research and Engagement from Tree Canada, to introduce today's e-lecture speaker. With that, I will now pass it over to Dr. Ursula Eicker.
Thanks, Sharon. Good afternoon, everyone, and thanks again for taking the time to join us today for this second e-lecture in the series. On behalf of Tree Canada, we're pleased to be bringing together forestry professionals to learn from these allied professions on shaping urban forest futures. Thanks again, Sharon, and the team at CIF for hosting these e-lectures with us. So I have the pleasure of introducing our speaker today, Dr. Ursula Eicker. Dr. Eicker is the Canada Excellence Research Chair in Smart, Sustainable, and Resilient Communities and Cities, and founder and director of the Next Generation Cities Institute at Concordia University in Montreal. She works on decarbonization strategies for cities using livable labs and urban digital twins for scenario modeling, user engagement, and operational optimization. Her research interests cover zero emission and smart cities, renewable energy integration, and sustainable urban infrastructure. With a team of about 50 graduate students and software developers, she is working on multiple eco-district projects in Canada and builds the urban modeling and data analytics platform Tools for Cities. Dr. Eicker has published 8 books, 20 book contributions, over 140 peer-reviewed articles, and more than 340 conference papers. So thank you, Dr. Eicker, for sharing your time and insights with us today. Please go ahead.
All right, good afternoon, everybody. Thanks for the introductions and greetings from Montreal. So I suppose I'm one of the allied professions. My background is actually in physics, but I have a couple of students working on urban green infrastructure as part of the big sustainability, livability themes that we work on here at Concordia. So when I came here 6 years ago now from Germany, I basically got together a lot of researchers at Concordia who are working on city-related topics. And I guess the ones that are most relevant to your profession are actually in the Built and Natural Environment Research Cluster. We have a big biology department. We had some, together with my chair, 5 young city cluster hires, one of which is an urban ecologist, Carly Seiter, very active in that field, and she is actually co-supervising the students that basically produce the work that I'm talking about today. We also work a lot on community engagement, outreach, and have some colleagues leading that cluster. And then we deal a lot with data, and I'll show you a bit what we're doing there. And there we have people from computer science, mobility research, cybersecurity, and so on. So if you look at topics that we deal with in a city, it's of course a huge field. I mean, it involves the physical transformation of cities. If we talk about zero emission strategies for buildings or mobility, the whole sort of greening of cities, access to green spaces also belongs to this physical transformation side. because we are here at the university, we do work on locations in the city, but we also try to build digital models of cities, and I'll show you some of that work to basically run scenarios, what if scenarios, or calculate the impact of a certain choice on building efficiency or carbon sinks of greenery or so on. We also look at how, when we talk about transformation scenarios in cities, how can that actually be financed and by who? And that means we need to talk to a lot of stakeholders. I mean, from the public sector, from the private sector, of course, the citizens themselves. And that's this kind of complex conglomerate. I think that's what you need to tackle if you really want to move to a more sustainable city. And just to start with, before I go a bit into two more specific topics from the PhD students, I just want to show you a bit of an overview of what we do on this sort of digital twin side. So we basically have a lot of data available in cities, not very organized, not very structured. And we work on sort of harmonizing that data, then applying models on the data to, for example, calculate energy performance, emissions, cost of transformation, whatever we're interested in. And then we have some interfaces that make all this initial data and the process data or the model scenarios easily accessible for different users. So we have a more gaming type of interface, and we also have web applications which are even easier to access than running a game engine. And just to show you a bit how that looks like. So when we started to basically build these digital models of a city, we basically had a look of what is available in terms of open source data for any area actually in Canada or worldwide. So we do actually have pretty good data on the built infrastructure of a city, because you would always find footprints. You find building heights. It's not always very correct, so there needs to be some kind of data cleaning to be done on many of this urban data. We do have data on mobility, on energy systems, and so on. And we basically built this web platform, City Layers, to first of all make the data available so that people can look at whatever domain they're interested in, or run models. I mean, here we're running transportation models for different modal choices in a city. So you can also use that interface to basically parameterize a model and start running some simulations and change something and then run the simulation again. So that's what we are basically trying to combine. And because it's quite a bit of video, let me just move a bit further ahead. Of course, we don't just look at the built infrastructure, but also at material flow, material resource flow in the city, for example, waste collection. And then, of course, at the information that we find on green infrastructure. And so there are pretty good public tree registers in at least for the Montreal area. So we include that in the database, and then you can sort of combine these different layers. And when I talk about one of the students' work on walkability, that's exactly what she does. She needs these sort of 3D models of a building and of the trees actually to, for example, calculate shading and urban heat island effects. So that is one of the interfaces we are building. The other one, so once you've got this 3D model of a city, then of course we asked ourselves, nice to look at data, but in the end, people want to see the impact of certain decisions. And we had this question of, in most densification project of a city, do people really like these kind of high rises? If the city decides to increase zoning, how would it actually look and feel? And if you put the same model that you saw before on the web interface into a game engine, then you can sort of play with the heights, play with rolling out green infrastructure, have people play little games and give them tasks, and I mean, and especially get a feeling on how that would look like and what you think. So we're now working on with the Office of Public Consultation of saying, can we use that to have people give feedback on certain strategies, like, as I said, building heights, but you could also have greening strategies or transportation aspects, and then collect this feedback from multiple people that have a look at this, at their neighborhood, change things, and then report back what they think. So, and as I said, then you can also
quite a nice touch of nature.
Have little.
The city really should work on this public hygiene. This is very scary.
Let people sort of give them certain tasks to do, and I mean, whatever. I mean, you know that in game engines you can do plenty of things. So we're just exploring several use cases where you can use this kind of easier accessible interface to come up with scenarios, and the same is greening. I mean, we had this project here in Chinatown where people basically had still some open spaces, and then we made this little game for them where you offer them certain things they can place, and that of course includes public infrastructure, but also trees and so on. And in the end, we would calculate sustainability indicators. So, and they are pretty broad actually. They're not just related to emissions, energy, comfort, but also to safety and so on. So you can basically play with that kind of setting, and then you get an evaluation based on a bunch of metrics, sustainability metrics, and you get an evaluation of your design, and then you can try again, and in the end you find out what people sort of value most and create this more participative design space, and have people, of course, leave comments. And as you see here, so it's it was too short. Sort of safe. There were several aspects that could be that were evaluated, and then also we put some best practice ideas that you learn from these kind of interfaces. Then my colleague Kali Seiter from ecology, her students wanted to have a kind of similar tool to design more specifically green spaces, and of course they had a bunch of research questions around that and wanted to find out, does it depend on the socio-economic status of a neighborhood, what kind of choices people would take. And in general, how do greenery preferences depend on the location you are living in, and then what types of greenery do people prefer, and so on. So we basically designed this. I mean, we means my team of more engineers, computer scientists, designed that tool for them to look at your ideal green space. So it basically is a combination of designing the past infrastructures, and then basically having various options of what you could actually put there. And in the end, as I said, you would again get an evaluation of the scenario you choose. So I think all this, that was just to give you a little teaser at the beginning of the kind of tools we're developing, more quantitative tools where we process data and calculate emission sustainability metrics, or more interactive, a bit more playful kind of tools where you have a more direct connection to your stakeholders, so that you get a bit of an idea of what these sort of digital twin things actually mean and how we fill that with life. All right, so now I want to talk a bit more about, I try to get rid of the bar here, just in my way. Let me just put this down here. So a bit more in depth on a couple of projects that I run actually with Kali on urban greenery and the relation of urban greenery on quality of life. And there's 2 PhD students that we co-supervise. So Lingshan works mainly on the relation of greenery and urban heat island effects and air pollution. I come back to that at the end. And Fateme works mainly on walkability, but because these effects are interlinked, I mean, how much green infrastructure you have in a city will impact all of these criteria. I will show you a bit what they've been working. So I start with the work of Fateme on walkability. And she's trying to set up or basically expand a framework to assess walkability in cities with a special focus on street level greenery. Because street level greenery has an impact, of course, on thermal comfort, whether you get shade or not, but also it's just visually pleasing. It might increase your desire to go for a walk. So she's looking at expanding the sort of typical walkability criteria that you see here, metrics that allow you to calculate walkability indices. She's trying to expand that by adding metrics around greenery. So what does it actually mean? So if you look at sort of typical walkability metrics, I mean, that we talk about a lot when you hear ideas on 15-minute cities, sort of reaching amenities within 15 minutes walk. I mean, those are basically metrics around accessibility. How much access do you have to services, to healthcare, to schools, and so on? What can you do by walking or biking in your direct neighborhood? And so what she's working in is taking into account the effect of greenery, which has, of course, an impact on thermal comfort, but also can make walking just more pleasurable. So that's of course more difficult to quantify, but I think there's clearly a relation between greenery and the walkability of a space, and we're trying to look at quantifying this. So she's built this larger framework where we look at different types of input data. And what I've shown you at the beginning is the 3D model of a city, where you have all the buildings and also the trees available in the model. You can use that directly to calculate the shadow and see the space that you're interested in for walking. Of course, it's the sidewalk, and how much these I mean, not just the trees, because the buildings, of course, also cause shadow. How much shadow they produce, do they give a sense of enclosure of a space? So that's one aspect. But then the other aspect that is novel is saying, well, how can we take into account the different aspects of green spaces or trees around street segments, street level greenery, to add to this pure sort of effect of greenery, like shade and enclosure, to have this sort of more qualitative description and how that would add to walkability. So of course, because there's many factors going into that, you need to think of how to weigh the different factors and then come up with a green and comfort walkability index on a street segment. So that's basically her work. And first of all, you need to know how much street level greenery is there. And there's different ways of measuring this. And how do you measure this? I mean, there are, of course, the top-down measurements, the satellite-based remote sensing images, which are used to calculate the normalized difference vegetation index. So basically seen from overhead. But we saw that would not be sufficient to really characterize what happens on a street level, because you might have a sort of grassy area, so which gives you a high NDVI, but no trees, for example. And on a street level, of course, the sort of percentage of your human view factor that is covered by greenery might be pretty different. And so that's something that Vladimir has been working on. So the first task was, of course, to say, well, how much of your view field, if you see here the images on the right, does actually have greenery. So that means you need to do some image processing to figure out what the trees, for example, or shrubs are. And then what we do actually, so we use OpenStreetMap, and every 50 meters, at every 50 meter interval, you take the images and then go through some image processing to basically come up with a analysis of that picture, and then you have every 50 meters a percentage of greenery in your visual field. So and here you see some results, and just to give you an idea of what we're talking about. So this first picture would have around 60% up to 60% green view index, and that can go down to 0 if you have absolutely no green, and in between, sort of between 20-23%. So doing this on every street level, on every street segment for the whole island here that you see of Montreal, then we have this classification of the green view index, which ranges from green, so with high green view indices of 60% or more, down to 0 or 10-20%. So it's very low indices, and you see it's spatially quite spread out. So and so I'll come back to that later as well. You can already imagine that there are areas in the city which are greener than others, and we also try to correlate that then with socio-demographic factors. So as you might know, if you've been in Montreal, the West Island is in general much greener than, of course, the downtown areas. You have got Mont-Royal in the middle, and so the greenest NDVI values you can. The greenest NDVI values here in this hotspot analysis you find on the West Island, and I think there's a slide. I think on the right one should be the green view index. So because we compared basically the satellite-based image with the street level index, and I show you a bit how that actually differentiates, because it's hard to see here on this overall map. So because typically NDVI would be used to assess urban greenery, and we think there are areas where it actually correlates well. So both, if you have a high NDVI, you also have a high green view index, or both are low. So the sort of dark blue or area in the orange is where it goes in the same direction. But you see also there's quite a few areas where NDVI is low and GVI high, or vice versa. The pink and the green ones are different, and that can be, you can see that here on the images on the left. So when they both are similar, both go in the same direction, would be a situation like that, sort of with trees in that picture. So you see you have a high NDVI, you've got grass, so and also the green view index is high, or you have nothing, more or less nothing, and both indices are low. But then we have these two situations here on the bottom. And if you look at the bottom one, which basically no large trees, but still significant grassy patches, the NDVI would actually be high, because it's seen from the top, it would be give you a high NDVI. But from the street level, because it's flat, it doesn't occupy much of your visual field, the index is low, and vice versa. In this picture with high trees, the GVI is higher than the NDVI. So yeah, I think this shows it again a bit more in detail. So these kind of high green view index and low NDVI sort of are areas where you basically have a lot in your view field, like trees, flower boxes on the facades, vegetation under bridges, which you just don't see from the top. And vice versa, these low-high clusters are where greenery exists, when seen from the top, but you don't have much in your view field. And that just shows, just using satellite image just doesn't give you the full picture of what greenery means when you walk around a city. That's the main conclusions. And then we sort of try to correlate that with sort of other data that we have from cities, like population density or road density. And as you expect, I mean, the more roads there are, the lower the green view index. There's a lot of scatter, of course, because it's not, there's a correlation, but the correlation coefficient is not that high. Same with population density, not such a strong correlation. But of course, I mean, as you can imagine, if you have a neighborhood that is dense, you often just don't have the space for planting. And but you could compensate that by having more green integration on facades, on balconies, and so on, and make sure that you see it, so that you still have an impression to be in a sort of reasonably natural environment. And yeah, as I said, higher road densities lower the GVI. Taller buildings, of course, the same. You see less greenery because it sometimes blocks the sight lines to vegetation. And again, placing trees more strategically, that you have a significant view of greenery really helps. And I mean, large trees are in that sense also very essential to have good high green view indices. So the high greenery actually is positively correlated with the green view index. And so as a conclusion on that part of the work, I mean, it's really recommendable to use both indices for policy making to get just a more complete picture on urban greenery. So, and finally, I mean, once we had this assessment of the available green infrastructure, Vladimir also looked at the impact of greenery on outdoor thermal comfort, which I mentioned already before, because of course shading would improve summer comfort. And we did that actually on a concrete project here on the west side of the island in Nashin, where a big area gets currently redeveloped. It's a brownfield, sort of very mineralized surfaces. And so basically there's not much, if there's a few buildings left on the site here in the middle, but mostly it's going to be new construction. So we couldn't use our existing city model, but had to generate sort of types of neighborhoods in that area, given the master plan that the city has developed. And I think at that point, once you're in this debate on a master plan, I think it's really important to show what the impact of choices are. I mean, so with these kind of tools like the city engine, you can say there's so many apartments I need to build in that area, and then you basically can generate different designs. And this was one of the designs that came out of it. And then we looked at the impact of greening that area and putting more or less trees and so, and see what kind of impact that has on the thermal comfort in that area. So there's a lot of data here. So I just point out maybe a few points. So if you look at a hot summer day, so she calculated the mean radiant temperature here at these different points of the area. And of course, there won't be a uniform temperature. It depends whether you are in between buildings, how much shade there is, whether there's greenery around or not. So your distribution of temperature levels is, of course, goes over quite a wide range from, I mean, on a hot summer day between 29 and up to, I mean, here you don't see the highest scale of 54 degree, but you see a lot of orange around 40 degree C, especially in the areas where there's no shading, of course. But you see a bit how from these different points the temperature vary quite significantly, and the average of the site was actually very high, of this 47 degree. And then these scenarios, this scenario A with absolutely no trees was compared to a scenario with 264 trees, which is about 19% of the site cover. And then more trees covering about 23% of the site. So if you go from the scenario with no trees and an average temperature of 47 degree, then you already go down by 7 degree. And if you have more trees, you go another degree down. And I mean, in the same line, I mean, we looked also at the temporal distribution. So 67% of that day you would be above 41 degree. And that, of course, also comes down significantly if you plant the trees. I mean, nothing too expected, but I think it's still important to for a start show what it does. I mean, as I said, you can get really a temperature decrease by over 20 Kelvin, which is really significant, but it also shows you where to plant the trees, because sometimes in between the buildings, you might already have good thermal comfort due to shading from the buildings, but you have these sort of big open spaces. If you don't do anything, it's just going to get incredibly hot. I mean, here you're really talking over 50 degrees. Especially here, we also look just at the sort of the daytime temperatures, just between midday and early evening. So, the key takeaway from her work is, I mean, that this combination of 3D city modeling and climate simulation, especially for the thermal comfort, is pretty powerful to tell you what greening can do. And trees, as everybody knows, I guess, are pretty essential for these sort of heat island mitigations. And it's important to put the trees where they can really best help reduce that spot. So once you've got the model, you can also look at lots of other sort of variables like surface albedos that also have an impact. And yeah, I mean, this combination of tools to assess the walkability index as such, but then also look at thermal comfort and the impact of the green view index on walkability is a really key outcome from that work. Okay, now I want to move to the work of Lingshan. She looks actually at the impact of greenery composition and configuration. So you see here a couple of icons of composition and configuration. I explain that later. And of course, also looks at the impact of the composition configuration on temperature levels. I mean, I think that's the easiest to measure comfort indicator. But in addition to air temperature, there's also air quality, which is improved by greening in the city. So, and then again, looking at the correlation of where do we actually have these green spaces and how are they correlated with socioeconomic factors. So there's definitely also an environmental justice piece in here. All right, so composition basically means how much of your area is covered by green space. So without taking into account how exactly this is arranged, it's basically a classification of an area in terms of the amount of greenery you find on a certain plot area. Whereas configuration has many indices that really goes more into detail and tells you how are these different entities configured, how they're physically distributed, are they aggregated, disaggregated, are high and low vegetation mixed, and so on. So the configuration has more metrics actually to describe the very specific setup of greenery on a given site. So she basically also tried to look at an analysis method to explore these effects of composition and configuration and what it would do to temperature levels first and how it correlates with socioeconomics. And then in a later stage, she also went into more detailed measurements on specific parks, and I show you some results from that experimental work as well. But the first thing was again based on satellite data, so measurements of land surface temperatures. And of course, if you have measurements of land surface temperatures, I mean, you can already see that in the inner city areas, temperatures are significantly higher than on the sort of outskirts here, with lots of greeneries and natural parks here on the West Island. And then you can overlay that with sort of data from the census tracts, where you have a lot of information on the socioeconomics of a specific area. So the idea was to say, well, how much sort of ecosystem services do we have in a given area? So bringing down temperature, for example, that would be sort of our supply. So the green stuff, the greenery has a certain function. It provides cooling, for example. And how much demand do we actually have? And demand might just mean, do we have vulnerable population, like older people, children in that area? And how does it actually correspond in areas where we have a lot of supply of green services? And does it actually correspond to places where old people live, for example, or not? So that was this question of how do these things actually correlate? So and this graph shows a bit what we've seen in terms of supply and demand for cooling. So again, this is now sort of summer, and you basically look at the temperature decrease of land surface, the land surface temperature decrease compared to the medium value in a certain area. So how much does the temperature level decrease in a certain area? And so by using regression analysis, Lingshan found a correlation between land surface temperature decrease and high and low vegetation levels. Of course, high vegetation levels are more significant to bring down temperatures than low vegetation levels. So we have basically for every area in the city a matrix of the supply, how much temperature levels were brought down in that specific area. And demand, as I said before, we look at the percentage of vulnerable population, so aged over 65 or below 5 years old. So that would be the demand. And you see, I mean, that is sort of less uniform. So you have some areas with sort of high demand, sort of very vulnerable population or aging population, but they're not all in the same area of the city necessarily. So you have high demand, sort of aging population here in the southwest, but you also have some in the Montreal north. So that is a bit spread over the city because there's of course different reasons for finding these kind of populations in different areas. And then basically she calculated the mismatch between the two. So that's basically supply minus demand. So if the supply is high and demand is low, you have a lot of green services. So it's nice and cool, but you don't actually have much vulnerable population. So the more positive the darker blue actually the area is. So as you can see here in the green sort of natural park areas in the West Island, you have a high supply but very little demand. And then you see here in this sort of hotspot analysis that the biggest mismatch is actually in the Montreal North and here in more central areas where you have more vulnerable population but very little ecosystem services. And then, as I said, we correlated this supply minus demand mismatch. So, I mean, the higher the value, the better. I mean, the more green ecosystem service, the less vulnerable population. So the richer the area is, the better the ecosystem services. That's what we see in many cities, and that the greenest places are actually where the richest people live, and negatively correlated with percentage of visible minorities, or with people with no certificate or diploma, again, the amount of ecosystem services goes down compared to the demand that we have. And the higher education levels, which often goes together with higher incomes, also positively correlates. So you clearly see that there's a correlation between status, socioeconomic status, and cooling supply by green spaces. All right, so the last topic I wanted to bring up from Lingshan's work is sort of more experimental work she did in parks, to go now a bit more into detail, a bit like I showed before. I mean, the Green View Index already gives you a much more complete image of what happens in a city. And of course, if you compare to satellite measurements, and the same, of course, if you go now into specific parks and you look at composition and configuration of vegetation in these parks, does it really make a difference in terms of temperature levels and air quality? So she did some measurements in 13 parks to measure temperature and relative humidity, and then we did also some field work on air quality. So I show you some results of that. So again, comparing basically sort of more open area with discrete tree clusters and then more aggregate tree clusters, and seeing what impact that has on temperature levels. And okay, this shows basically the results. I mean, all the results of mean temperature measured during the daytime. Those are all the red values. So you have the histogram, the counts of daytime temperature measurements and nighttime temperature measurements. And what you see, I mean, during the day, and this is compared actually to a temperature sensor outside of the park, on a basically in about 50 to 100 meter distance, typically measured on a parking lot outside the park. And you see during the daytime, the sensors inside the park were even higher than the reference sensor. But during the nighttime, the open areas with grass were significantly lower. And vice versa for the tree clusters. So, I mean, the best cooling effect, as you might imagine again, is when you have sort of dense aggregate tree clusters. This gives the lowest daytime temperatures, and so lower than discrete tree clusters during the day, and then during the night temperature, because the heat can't escape as well as over free surface areas. So you have slightly higher temperatures, pretty similar temperatures actually in these two cases compared to the open grass areas. So I would say nothing too surprising, but that now sort of shows a bit what these different configurations actually do to temperature levels. And then we wanted to see, do we actually see something in the data also for air pollution levels? And so she also did some measurements in different parks for NO2 and ozone, basically. And again, compared different configurations of trees, like linear plantings or more group plantings. And yeah, and basically try to measure pollutant levels. Of course, it's not such an easy, it's not so easy to say what actually happens, because there's a lot of reactions of trees with different pollutants. So, I mean, the trees do absorb ozone, but also ozone reacts with nitric oxide to form nitrogen dioxide, and that again is absorbed by trees. On the other hand, trees also emit biogenic volatile compounds, and they again do also react with NOx to form ozone. And the more ozone, the higher the temperature levels. I think that's sort of the general mechanism. So we didn't expect easy answers from that experiment. And here's again the kind of situation. So we wanted to see is there any difference between linear tree clusters and group tree clusters. And so we had, so again, reference measurements on the roadsides, and then basically on the line of the linear tree clusters in the park interior, and underneath the group tree clusters. So what do we see in terms, does the configuration of trees actually impact the temperature and concentrations of NO2 and ozone? So the first one was the nitrogen dioxide. So what did we see? I mean, it looks pretty chaotic, and basically the effect is not very clear. I mean, let's maybe look at the linear planting here. So the different sensors. So on the roadside, at the location of the tree cluster and in the park interior, you don't really see much difference in the nitrogen dioxide levels. And again, on the let me see, for the group planting, you had basically the highest NO2 levels just at the location of the tree clusters. So a not very conclusive result, I would say. So it seems that the tree clusters seem to even accumulate NO2. So we didn't really see any reduction from inside to outside of the park. And yeah, more or less the same picture in these 2 months of measurements, July and August. For ozone, it was a bit different. I mean, for a start, we had significantly higher temperatures in July than in August. So basically the July results, the ozone levels were in general much higher than in August, what you see here. And there actually we did see a decrease of ozone concentration, both for the linear planting and the group planting. So at the locations of the trees, the ozone concentrations were actually lower than in the open space in the park interior and then on the roadside. So here in both months you saw an effect, but you basically also see that temperature actually is nearly more important than the location of where you are. So I think that, so this is was a result from that experimental study. So the air pollution effect is much more complex to analyze than the temperature levels. So we did see, of course, very significant spatial differences between greenery and temperature reduction. I didn't show you, we did the same measurements also for the parks. So that, of course, is very strongly related. Same for air temperature, shows basically that the aggregate tree clusters provide the strongest cooling effect in the daytime. And we see similar temperature reductions on these larger spatial levels as measured by satellite imagery. From the satellite imagery, you could really say that areas with high supply of cooling are typically in areas with high income, high education levels. So there's a significant social justice piece in here. And we can also see that during the day, these aggregated tree clusters reduce land temperature surfaces more than distributed green spaces or open green spaces during the day, and vice versa during the night. As I said, the pollution measurements were less conclusive, I would say, on a local scale of what really the effect is. But it is quite clear. It depends a bit on what you want to achieve. If you want to have daytime cooling because the spaces are used a lot during the day, like in schoolyards or so, trees in aggregated planting configuration perform best, also lower ozone, as we have seen. And final words, maybe I would say, like from my perspective as an engineer on dealing with sustainable cities, I think it's an extremely important topic to deal with greening strategies, because that's what most people are really interested in, and often drives the sustainability dialogue. And of course, greening is essential for health, for mental health, for walkability, for inclusion. And so we need to make sure that access to green spaces is available everywhere in the city, and especially in areas with vulnerable population. That needs to be improved. And there's a clear effect, clear correlation between greening and reduction of urban heat islands. So that's clearly on the positive side as well. And that concludes my presentations. Thanks for listening, and open for questions.
Thank you, Ursula. That was a great presentation. And thank you for demonstrating tools for City. I'm sure I won't be the only one exploring the platform after this e-lecture session. Before moving on to the questions, I'm going to launch a post-webinar survey. Just a reminder that there are 2 questions in total. You may need to scroll down to see the second question. All right, Ursula, the first question for you is, one of the challenges with densification design is the expansion of above and below ground service infrastructure, such as hydroelectricity. Do you have a surveying layer in your design modeling that can be consulted? Does your modeling consider future expansion of service infrastructure?
Yeah, great question. I mean, I would love to have that layer, but Hydro-Quebec is extremely unwilling, let's say, to share that information. I mean, for all kinds of reasons. So it's not just unwillingness. I mean, there's of course, some security issues here involved. So, I mean, distribution grid data is not publicly available. We do have transmission data, and yes, we do have that information, but we are, of course, mostly interested, as you said, interested in what is really underground in a city, and because it's important for all kinds of capacity expansion. I mean, the whole electrification debate that we have of electrifying transport, electrifying buildings with heat pumps and so on, it all relies on existing cables that were never really designed to take all this electrical power. So we actually work on basically creating our own models for distribution infrastructure, because we know we know how much demand we have in every building, and we know more or less what the typical distribution network would look like. So we basically recreate that from what we assume, but we don't have the real data, unfortunately. But yes, I mean, that's a huge topic, because for, as you said, for city densification or even electrification of existing infrastructure, you need to know are the existing transformers large enough to take the additional load? Are the cables large enough to take the load, and so on? So it's a very important factor. And typically what you do if you would have a city expansion, or you build, add new buildings, you would say, well, I want to have 100 new apartments on that area. And you go talk to Hydro-Quebec and they tell you, we have the power, or we don't. So that's how it works just now. You come with your project to Hydro-Quebec, and they, of course, will inform you how much electrical capacity is available on that site or not. But it's not publicly available.
Thank you, Ursula. I think we have a comment in the chat. That was amazing. Thank you so much for your talk today, Dr. Eicker. How can we stay up to date with your future research projects? My colleague and I have an app that we are developing called Community Trees to gamify urban forest management. I would really appreciate the opportunity to learn more from you.
Yeah, that sounds great. I mean, we have, I have one person in the team, Chris Gibbs. I can put the email in the chat. He's basically leading all the game design because he used to work for Electronic Arts. He ran game studios, and so he's the guy to talk to. I mean, we would love to see what you've been doing on that app, because we develop a lot of tools, but we typically don't have the time or means to really test them on a large set of users. So it would be great to collaborate and see whether either we can combine tools or give you what we have. I mean, what we develop is all open source, so it's shared. I mean, the gaming tools are using Unity, so which is not open source, of course, but whatever we can, whatever we have can be shared. And if you have ideas of how to collaborate or test different sort of prototype games that we develop with people you know, sure, reach out. I mean, to me or to Chris. That would be great.
Thank you, Ursula, for sharing the email address. One more question for you is the data collection and analysis tools and model available to practitioners to guide planting plans?
Yeah, as I said, this tool specifically on the planting was developed by Chris with Kali Seiter's team. I would say 95%. I'm 95% sure that she would be happy to share it, but I can't speak for her. I mean, I would say from our side, yes. I don't see any reason why we shouldn't share it. And I know that Kali is very motivated also, and she does a lot of public outreach to speak to diverse communities about what to plant. So she typically loves that kind of activities. So I'm sure she would share. Yes, same thing. I mean, the tool as it is, it would be great if it gets tested more and expanded. Of course, it's probably not complete in terms of what species are available, and I don't really know in detail of how much they've implemented, how many native species they have in there. Yeah.
Thank you, Ursula. My question is, are there plans to expand tools for cities data coverage to include more municipalities across Canada?
Yes, definitely. Yeah, we're working already. I mean, we have a first contract with the city of Quebec to basically do a full digital twin for Quebec City, and we're working in Toronto, and we have a new project it's more on community energy solutions, but if the data is there, it's of course very easy to also include greenery aspects. And I think that's definitely the goal, to see how much can we harmonize the data collection process so that, I mean, all our models would run on any city. It's more a question, did somebody sort of clean the original data? And we're starting to work on that and finding out how much effort that actually is to start with. And we looked at, I would say, the major Canadian cities. We already looked at what data they have. So like Vancouver, Calgary, Toronto, we looked at all these cities, and we have quite a good view of what is available and what isn't. So yeah, the plan is definitely to roll it out as much as possible, and even create a sort of larger Canadian type of project, maybe with the National Research Council, to really make that happen.
Yeah. I guess we'll stay tuned on that. All right. If there are no more questions, I would like to bring this e-lecture session to a close. Thank you all for participating in the CIF e-lecture session. And thank you very much to Ursula for the great presentation. Bye, everyone.
Thank you.